It includes waves, classification of waves, nature of sound, speed of sound, and characteristics of sound. Waves. It is a disturbance that carries energy and travels through an empty space or a medium. When we say medium, it is a material through which a wave transfers energy. Can be solid, liquid, gas, or combination. An important thing to remember about waves is that waves only transfer energy. We can see that in the video. As the waves goes through, the duct moves up and down, but once the waves are gone, it is back to its original position. The wave has carried energy through, but it did not carry the duct in it. There are two classifications of waves according to its nature. First is the electromagnetic wave, and second is the mechanical waves. Mechanical waves may be classified as transverse waves or longitudinal waves. Observe the video. We see that the vibrations are perpendicular to the direction of travel of the wave. These are called transverse waves. An example of these waves are waves in water, waves on a string, or light waves. That means all electromagnetic waves are transverse waves. On the other hand, longitudinal waves are one in which the particles of the medium vibrate parallel to the direction of wave propagation. The very common example of longitudinal wave is sound waves. Sound is a longitudinal wave that is produced by vibrating objects and is capable of producing sensation in an organism's system. The sounds that we hear every day may be classified either musical tones or noise. Musical tones are produced by regular vibrations, while noise is made by irregular vibrations. Sound waves are vibrations that pass through the molecules of a medium. Since sound wave is a longitudinal wave, it travels as a series of compressions and rarefactions. Compressions are where the vibrating particles are closest together, while rarefactions are the regions where the particles are farthest apart. Since sound waves need particles to be transmitted, the more densely packed the particles are, the faster the sound travels. This is why sound travels faster in solid than in liquids and slowest of all in gases. In movies and on TV, you'll sometimes see and hear things exploding in an outer space, alien spacecraft, and things like that.
Control, I have visual on the arm, over.
Affirmative, Major. Proceed.
Copy that. Moving to the unit now. Control, I'm seeing a power surge on C-post. You getting that?
Roger that, Roy.
Control, we got a lot of people up there, over.
Control, I think we have a fight. Stand by, we're working the issue. Stand by. Control, they're happening everywhere.
Is that really possible knowing that we know about sound? An important point is that as sound waves pass between different mediums, it speeds up or slowed down. However, the frequency doesn't change. The wavelength gets longer as sound speeds up, and as sound slows down, its wavelength gets shorter. Since sound changes speed as it moves from one medium to another, means that sound can be refracted, absorbed, and reflected. A sound wave is reflected when it strikes another body, and the sound that is heard after reflection is called echo. Did you know that reflecting surface has to be at least 17 meters away from the source in order for the echo to be heard? Did you know that some animals use echoes to navigate and find food at night or in dark locations such as caves? This is known as echolocation. Some examples are the bats, whales, and dolphins. Sonar, or sound navigation ranging. It is used to determine the depth of water and to locate a school of fish, submarine, or others. Did you know the Titanic was recovered using sonar? Did you know that you can hear sound from a greater distance at night than in day? In daytime, the hot ground warms the air so sound waves travel faster. This makes the waves refract upwards. At night, the air is colder at the ground, so the sound waves are refracted towards the ground. The speed of sound also depends on the temperature of the medium, but in this case, we will focus on the speed of sound in air. If the temperature of air increases, the molecules of air have more kinetic energy. Hence, it vibrates faster, thus increasing the speed of sound. When temperature of air decreases, its kinetic energy also decreases. Thus decreases the speed of sound. At 0 degrees Celsius, sound travels at about 331 meters per second. We can calculate the speed of sound in air using the formula. V equals the speed of sound at 0 degrees Celsius plus the quantity of 0.6 meters per second degrees Celsius multiplied by the temperature. In short, V equals 331 meters per second plus 0.6 times temperature, wherein V is the speed of sound in air, the unit is meters per second, T is the temperature, and must be in degrees Celsius. Sample problem. Sound travels in air at temperature of 20 degrees Celsius. What is the speed of sound? Let's use the GAPSA method. Given, ask, formula, solution, and answer. Now, what is the given? Temperature equals 20 degrees Celsius. Ask is the speed of sound. Formula. V equals 331 meters per second plus 0.6 times the temperature. Try to solve it on your own. Solution. V equals 331 meters per second plus 0.6 times 20 degrees Celsius. The final answer should be 343 meters per second. Pitch refers to the highness or lowness of sound. Frequency is interpreted by our brain as pitch. It is the pitch that makes us differentiate the frequency of two sounds. To understand this, let us consider these two sounds. In case of a blowing whistle, the waves are moving fast, hence the frequency is high. Thus, it produces a high-pitched sound consisting of short wavelengths. Here, the waves are moving slow, hence the frequency is low. Thus, it produces a low-pitched sound consisting of long wavelengths. Low-frequency sound waves equals low pitch. High-frequency sound waves equals high pitch. Now, listen to the different pitches. The loudness of sound is closely associated with its intensity. Example: if we strike a drum with lesser force, that is, if we strike it lightly, we hear a soft sound, as the sound produced is of low amplitude. However, if we strike a drum with more force, that is, if we strike it hard, we hear a loud sound, because in this case, the sound waves has a large amplitude. Did you know that sound waves with frequency below 20 Hz are called infrasonic waves? Common sources of these waves are heavy machines and earthquakes. On the other hand, sound waves with frequency of above 20,000 Hz are called ultrasonic waves, where it can be detected by some animals. And ultrasonic waves in the field of medicine are used to probe human internal organs instead of X-rays. Did you know that a human ear can tolerate a wide range of intensities? The faintest sound that it can perceive is called the threshold of hearing, while the loudest, tolerable but painful sound that a human ear can hear is called the threshold of pain.